Kiev in the Ukraine. Used to be part of the USSR, Soviet Republic, Russia before 1990 in Eastern Europe. We've come here to see not these domes but to see Chernobyl, which is one of the world's most radioactive sites after the nuclear disaster that occurred here in 1986, leading to a reactor core meltdown. And we're going to get up close. We're hoping to actually go inside the building where the melted reactor is. And I brought Tammy here. It's her birthday tomorrow. We could have gone to Paris. We were in Paris yesterday, but we've decided instead to come to Kiev and Chernobyl. Chernobyl now, driving from Kiev. We've been issued with Geiger counters. This is my Geiger counter. It'll measure my radiation dose for the day. We're also going to be entering the exclusion zone, which is 30 kilometres from the plant and then 10 kilometres from the plant, and to do that it's like a border crossing, so we're required to carry our passport. Interestingly, on the 26th of April 1986, when the Chernobyl power plant melted down and exploded and sprayed radioactive debris into the atmosphere right across Europe, Tammy and I were on our honeymoon, staying in Graz in Austria. We were staying with a friend of Tammy's who happened to be a nuclear physicist, amazingly, and so we found out that there'd been a nuclear accident in the Soviet Republic of Russia, and we therefore took iodine to saturate our thyroid glands to reduce the likelihood that we would develop thyroid cancer. So far so good, later in our lives. So we'll do hopefully some video clips. We're not doing the standard sort of look around outside. We've actually made arrangements to go inside the Chernobyl power plant, and hopefully we'll get some video clips while we're there. Just see out the front of the car now.
Добрый день, меня Лена зовут, я вам звоню от компании Chernobyl Tour. У меня 2 туриста к вам сегодня едут на станцию.
Okay, so we're at the first checkpoint. This is where we're waiting for the appropriate paperwork to get into the exclusion zone. Nuclear power plants are just like a big kettle. They just boil water. And if you don't have water and the kettle runs dry, then the reactor core melts down. And even though nuclear power plants make power, one of the biggest risks for nuclear power plants is if they have a blackout, if they lose power. And the reason for that is that the big pumps that pump water through the kettle and keep the kettle full of water stop. And so on that night when the reactor was destroyed, they were worried about that. And of course they had backup generators, big diesel generators, that in the event of a power outage they would fire these up. But there was this problem, and that was that between a power blackout and the generators coming online was 60 seconds. 60 seconds without power, and during that time it's possible for the reactor core to melt down. So they were performing an experiment to see if they could bridge those 60 seconds using another technology. And if we come across here, you'll see the checkpoint that we'll be going in soon, and see how we go. Now, it took us a while to get through the 30-kilometre checkpoint. There was some stamps and paperwork that took about half an hour to sort out. We've come in, we've seen radiation readings already that are triple or quadruple what we had in Kiev, and I'm standing now actually outside the nuclear power plant. We can't turn the video around because it's a strategic object, but you can see in the distance the 6th nuclear reactor. There are actually 4 nuclear reactors built here and operational at the time of the accident, and it was reactor number 4 that melted down, and reactors 5 and 6, it's 5 in the background, was built. So it was going to make this the largest nuclear power site in the world. We can't show you the building, but we're waiting for our special guide where we're hoping to actually get inside the reactor. Okay, we're now sitting in the control room for the Chernobyl reactor. This is where things would be coordinated in the event of a disaster, and we'll just show you around the room. Just behind us is a special room for communication with government authorities, which would have been the Kremlin in here in 1986. Up a bit here to the screen.
Oh.
Ready now to go to contaminated areas. We've been given some overalls that we have to put on. These are for my feet. This is a gas respirator, and we have gloves, and we've been told that we're not allowed to touch anything because this is a contaminated area within the Chernobyl building. Getting a bit more serious now. We've got our gloves to put on, our dosimeter to check for the radiation dose that we'll receive while we're inside contaminated areas, the coat, hat, my mask, and my gloves. Tammy's been somewhat concerned about how her hair will look after she takes her hat off, but now we'll start to enter the contaminated areas. I'm just walking through the remotely controlled gate, and straight ahead is the door to the actual reactor complex at Chernobyl. We're now standing in the control room for reactors 1 and 2. Actually, this is the switchgear control room, so this directs electricity around the Ukraine. It's still in active operation. So the equipment that you see here is mainly associated with grid control and electricity distribution as opposed to nuclear power generation. This is the famous Golden Corridor, the 1 kilometre long corridor that spans all 4 reactors, and off each side are the control rooms. To my right and to my left are the reactors. So we're now walking down the famous Golden Corridor. We've come from the first building, which houses reactors 1 and 2, and we're now walking towards the building that houses reactor 3 and reactor 4, which melted down its core. As we came between reactor building 1 and 2 into this area, my alarm went off just to signal an increased level of radiation. We're now going to walk into the building that houses the meltdown. Sitting at the control panel for the nuclear reactor for the 3rd nuclear reactor at Chernobyl. This display up on the wall indicates where the control rods, the rods that go down into the reactor, are positioned. And here on this panel are the buttons, which I can even press, that cause the control rods, which decrease the reactivity of the reactor, to be lowered. And this is the up and down control rod button here. This is known as the scram button. It's the AZ5 button, and this was the button that was pressed in the seconds before the explosion on the 4th reactor. And it was the pressing of that button that the operator didn't realise would inadvertently cause an explosion of the reactor. In the centre over here are a whole lot of dials that indicate the depth with which the control rods have descended into the reactor. And this control panel, with a few minor modifications, is absolutely identical to the reactor panel that the operator sat at. There were 4 people in the room that night, 1 at each of the 3 panels. This is the reactor control panel. The next panel controls the electricity distribution, and the last panel towards the far wall is the turbine hall. This is where the big turbines, a bit like an aircraft engine, take steam and convert it into power. So there was 1 person at each of these panels, and 1 person, Dyatlov, who was the senior engineer sitting at a desk here in the middle. We're now literally only a few metres away from the melted down reactor 4 core. My Geiger counter is alarming, and to my left is a concrete wall which is many metres thick. And on the other side of this wall is the melted reactor 4 inside the new containment vessel. And here we have a memorial to the one person that night whose body was never found. One of the people operating the water pump. And this effectively represents his last place on rest. Basically wandering around a half-lit, uneven floored nuclear reactor building now. Corridors off in various directions, a monitor that continues to alarm. And over here we have the one of the 4 water pumps that were responsible for keeping that reactor, the kettle, full of water. And each one could pump 7,000 tonnes an hour and weighs 700 tonnes. And if we just come this way, you'll see that there's 4 of these pumps in a row, and they are what keeps the reactor cool. And it was keeping these pumps running that was the subject of the experiment that was conducted that night, how to keep these massive pumps running in the event of a power outage. And the idea was the big turbine, the big steam turbine, was making electricity. So why not use that big steam turbine and the generator it was connected to provide electricity to these pumps to keep the reactor cool. So this is the monitoring of the new containment facility. So this is the arch that's been put over reactor 4, and you'll see that these are the screens, including running windows, slightly worryingly. And then this is the environmental monitoring, where the surrounding area, including the presence of earthquakes, and each of the green dots there indicating a region that's within an acceptable radiation limit. Some of the areas within the containment facility have radiation levels of 5 sieverts per hour, which is extremely high. Here, by torchlight, is the monitoring systems, the radiation monitoring systems in use at the time of the Chernobyl disaster. And what I'm holding is the memory core, where intersecting copper wires have a small loop of ferrous metal, and this is a computer memory core that was prevalent really in the 1960s, and I have to say I've never seen one of these myself, so that's amazing.
Just like a rock in English.
Thank you.
Спасибо вам большое.
In 65, technology, tape drives, they're all still here. We've come into this room right in the back of the power plant by torchlight, so that we've been able to see this. We've just seen a printer, one of the oldest printers from the 60s I've ever seen. So these were the monitoring systems in play, in use, at the time of the Chernobyl disaster. The reactor facility, and I have to check to make sure that I haven't, okay, my radiation limits on my surfaces is clear and I'm allowed out. So we've come outside the nuclear reactor buildings now, and this is the largest movable building ever constructed in the world, which is an arch which was constructed over to my left, and then once it was completed it was moved into position over reactor 4 to provide an isolation from the environment so that ongoing nuclear radiation was not released into the environment. This is the city of Pripyat, which was built for the Chernobyl power station. It was an absolute icon of Soviet achievement. People wanted to come and live here. Goods were available here that weren't available elsewhere in the Soviet Republic, like bananas. And this is an amusement park, and this hadn't yet quite opened. It was due to open only a few days after the accident occurred. These are the dodgems, and you can see how much the trees and other growth has taken over the entire place. Even the radiation levels here are approximately 20 or 30 times higher than you might expect just in other normal areas. And this is the Ferris wheel. It only ran twice in for testing, and then it of course never ran with proper people. So the Geiger counter is currently showing about 10 times or 15 times what you would expect normally. We're under the Ferris wheel here, and this wide open area was a convenient landing place for the helicopters that were taking bags of boron and sand to dump on top of the reactor. And there's a hot spot here which we'll just show you. So the Geiger counter is showing about 0.9 microsieverts per hour, and if we come over here and we just hold it here, first of all it alarms, and then it rises to 25, and you'll see that this increases. So we're up to over 165 microsieverts per hour in that spot. About 5 kilometres now from the Chernobyl station, and this is known as the Duga. It was a massive radar system which was designed to look over the horizon for incoming missiles during the Soviet era. And you can see that it's huge. There's a low frequency piece here, and then down the other end there's a high frequency piece. It's somewhat radioactive around here. But if you pan up, you can see the scale of this radar. There are any number of conspiracy theories about the fact that this didn't work, and because it didn't work, the Russians wanted to hide it from their superiors, so they blew up Chernobyl. And if you've seen the movie The Russian Woodpecker, which is made in Russia, it's actually banned in Russia. You can see some of the conspiracy theories associated with this radar or Duga installation.